Okay, everyone, now it's time for us to write our own model, create our own model. And we're going to create a model that is actually going to predict house prices, median house prices, based on the average number of rooms that they have. And it's by neighborhood, actually, so it's a little confusing. We're not just looking at the house price for a single house, we're looking at the average house, well, the median house price, I should say, in a neighborhood in the Boston area based on the average number of rooms for houses in that neighborhood. So what I'm going to give you is a data set that, well, I'm sorry, I'm not going to give you that. What I'm going to show you is the use of a data set that has 506 rows, which equate to 506 neighborhoods in Boston, and it has 13 fields, which basically give you details about the different neighborhoods that are part of this data set. What we're going to do is we're going to load up this data set, and then we are going to build a predictive model, and then we're going to sort of test out our predictive model and see how good of a job we did. Okay, so we're going to start up here by grabbing the appropriate libraries. Now, I tend to go heavy on my libraries, and I may have grabbed some that I don't really want to use or don't need to use, but we'll just go ahead and run through these anyway. Pandas I need for loading up my data frame, as you well know. The read CSV is part of Pandas, so I need that. NumPy, I don't remember if we use it, but I imported it anyway. We use matplotlib for our plots later on. SKlearn, from SKlearn, we're going to import linear model, and that's what we're going to use actually to build our predictive model. And then I've got some visuals that I'm using Seaborn for, so that will be available to you as well. So go ahead and set all those libraries up. Now, the next thing, and you can do this however you want to do this. You may have put your file, the data file that I'm going to give you. Oh, by the way, you're going to do this very same thing, only you're going to do it on a different data set and you're going to do it with different variables, but it will look very much the same. So what I will advise you to do is when you get your data file, go ahead and drop it into whatever directory you want, whatever folder you want. Ideally, it's going to be the folder that Python is looking in for those files. If not, you're going to have to change your directory. So that's what I'm doing here. I imported yet another library, which is the OS library, and it allows me to do what is my current working directory. When it shows me my current working directory, which is the result of this, then I can set that up. Let's run through the first part, which is actually to load up the libraries. That's done. Doesn't really give us any output. The second part is, what is my current working directory? My current working directory is downloads. So I'm going to change it to downloads, which is completely redundant and completely useless, but it just shows you how you can change it to whatever directory you want. So go ahead and set that up. Now I can read my file. I know my file is loaded in that directory. So I can do df, which is a data frame. I use the PD, which is pandas, read CSV, and I loaded up the exact name of the file in tick marks. And you hit that and load it up, and it's loaded. Okay. And so much of what we do in Python is we know it worked because it didn't give us an error. And this is a great example of that. Let's take a look at what we loaded. We just type in df. There's a number of different ways we can show this, but when we just hit df, it'll show us some number of records that are part of our data frame. So let's go through this real quick. We have our index, which is 0 through, Python starts with 0. So it's 0 through 505, actually. Then we have a number of fields that are variables about the neighborhood. And they have things like crime. They have Chaz is a 0 or 1 value. If you're 0, you're not close to the river. And if you're 1, you are close to the river. Number of rooms, age of the houses, what's the tax rate, percentage of people who live in lower economic status. So the two fields we're going to care about are going to be median value, and you can say this is median value in tens of thousands of dollars. So that would be a $240,000 house, and that would be $21,600 house. And again, those are median values, so it's the median value of all of the houses in that neighborhood. And we're going to compare that. We're going to see if we can't use room, the average number of rooms of houses in the neighborhood, as a predictor for what the median value is going to be. So we'll be focusing on this RM variable and the median value variable to build our first predictive model. We want to come on down and we see that we terminate out at 505 rows. It's actually 506 rows because we started at 0. Let's get set up then to create our linear model. And the first thing we're going to do is we're going to create a variable. And this variable is it could be anything. It could be house, it could be dog, it could be cat, but we chose reg, R-E-G. So that is a variable. And what we're going to do is we're going to set that variable equal to the linear model, which is in our libraries up here, the linear model, and specifically linear regression in the linear model. So that is what reg is. And reg, that's basically just, it's sort of like an uber variable, an uber command. So then now I can apply that command to two variables and create a linear model. Later, we'll use it to set up our linear model for median value and average rooms. Now we're going to set up our variables. And I'm going to use variables because it's easier. Instead of having to sort of refer to the actual text. So we're going to use x and y, and that's pretty basic. Our x is going to be set to the average number of rooms, and that is our predictor. So x is typically our predictor, so that makes sense. And y is going to be the median value, and it's going to be what we're predicting, and y is typically what we predict, so that makes sense as well. There's a very important note that I want to bring to your attention, and that is the sklearn linear modeling tool is a little picky about dealing with a series versus a series. Now, if you remember from your basics of your Python instruction in DataCamp, x equals df with double bracket forces a single array, because this RM, average rooms, 506 measures of average rooms, is a single array. It forces it to be a data frame. Whereas when we do y equals df with single brackets, it's fine having it be a series or a variable array. But if you have a single variable array and a single variable array, the linear regression tool from sklearn doesn't like it, and it will throw an error. So you have to set either one or the other to be a data frame, and that's just an oddity of the sklearn tool. So just make sure when you do yours, you set at least one of them to be a data frame, the other one to be a series. Okay. All right, we're getting ready to take a look at, let's go back and run some of these. I don't have to just talk about them. I can actually run them. I think this is the only one we haven't run here. Good there. And we're good here. Okay. So what do they look like when compared to each other? So we're going to take a look at a plot. We're going to plot x versus y. We'll label them appropriately using the PLT-X label and PLT-Y label. And we'll go ahead and do a PLT show, and gives us a plot that looks like this. Okay. So we range from about 3 rooms all the way up to 9 rooms in a house in all of those neighborhoods. That's the average number of rooms in those neighborhoods. And the median value is about $100,000 up to $500,000. So you can see that there is a positive correlation of some measure between the number of rooms and the median value of the homes in that particular neighborhood. That makes sense. It makes sense that the more rooms, the more you're going to pay for the house. Okay. But there's another way we can do this, and this is where I brought in the Seaborn library, because it gives us this reg plot. And what it's going to do is it's going to take the two variables that we have. One of them is room, the other one is median value. We specify the data frame that we're using, and we say, yes, fit a regression line to this and show us what this looks like. So we'll go ahead and run that. And it's pretty much the same plot as we saw above, but now it has a regression line. And this is going to start to give us a little bit of a tip-off of what our intercept and slope might be, because it already calculated it for us when it gave us the regression line. So when we look down here, we have to look at, okay, well, what should these values be? And what might they turn out to be, our slope and intercept? Well, that's what we're going to do next. So reg.fit, remember, reg is our variable. And what we did with reg is we set it up to be this linear model, linear regression. Now we're going to come down here and say, okay, reg, do your job. You're going to now fit x and y to be a linear model. So we run that. And we just get this output line that basically says, yeah, I did it. But we didn't get an error, so it looks like it worked okay. But let's just make sure. We want to take a look at the coefficient, and we also want to take a look at the intercept. So this would basically be our slope. Remember, oftentimes they're referred to both as slope and as coefficient. And what we do is we can use reg again. Reg is kind of our overall overriding command. And we want to say coefficient, which is COEF underscore. So that's how we get the slope. And it tells us that the slope is 9.102 and some, which basically means every time we go up by 1, we go up on the vertical axis by 9, or almost $10,000. Okay. So, but where do we start? So we do the same thing. Reg this time is intercept underscore, and it says we're going to start at negative 34. Well, that doesn't make sense. Negative 34. We're down here. We're less than 0 when we get to kind of the 3-ish area. But remember, the negative 34 is where x equals 0, and we're not even close to x equals 0 here. So if we scoot all the way over to here, x might be negative 34, or I'm sorry, y might be negative 34 once we get to x equals 0. It's kind of a meaningless sort of arrangement for this particular example, because we don't really start to care until x equals 3 or 4. but at least gives us a starting point so that when we have this starting point, we can use this slope to build the appropriate trend line that we need. So we have a slope and we have an intercept. Now we're going to start using it to apply it to the data. This is where the SKlearn module is really very useful and very handy, because instead of going through and using vector addition or vector math on a data set, what this does, and also instead of us having to worry about what the actual slope and intercept are, it already knows. It already knows what our slope and intercept are because it has this REG. Once we ran the prediction, it stored it in this REG variable. And now what we can do is we can say, okay, take what I have with X and predict a Y for it and drop that into a variable called df predict or PRED. That's a brand new variable, and it wasn't part of our data set. So it'll just create this for us. And for all 506 neighborhoods, it's going to take the X value, which is the average number of rooms, and it's going to apply the model it created and come up with a Y value, which is going to be a predicted median value. Okay? So that is how it works, and it's pretty slick the way it works. Okay, once we have that done, now we can take a look at what we have. So I'm going to go ahead and just print out from our data frame. We'll print out room, we'll print out predicted value and median value. And we get a list of them. And if you take the very first one, 6.575, and you multiply it by 9.102 and some, and then you subtract from that the negative, or that, well, it's negative, you subtract it 34.6706 and some, you're going to wind up with 25.175746. That is your prediction, and that's how we use those two values to take this X and come up with this Y. Our actual median value was 24.0, so we're a little off. And we're expecting that because it's a model and they're not always 100% accurate. But that gives you sort of a visual of how this model worked for us. Let's go down and take a look at a couple of other things. One of the things we want to track is we want to track the error. How good was our model? And so just like we did up here when we set up the predict variable, we're going to set up a new variable called error. So we're going to come down here and set up df error is going to be equal to df predict. That's what we just created, just calculated. And from that, we're going to subtract the actual, which is median. So for all 506 neighborhoods, we're going to get a brand new value that'll be in a 15th column. The 14th one was our prediction. The 15th one is now this new column, error. And it's going to hold the error, which is the difference between the prediction and the actual. So we'll go ahead and run that. And let's take a look at what we got. So remember, if we haven't gone through this yet, we'll go through it again, but remember the measure of error is a really important way to know how good our model is. But sometimes there's a whole lot of errors. In this particular case, there's 506 errors. So how do we summarize that or aggregate that to be a single value? So what we're doing is we're going to use something called mean squared error. And the mean squared error is basically what it sounds. So we are going to take the mean, but before we take the mean, we're going to access the error value from our data frame, and we're going to square it. So we square that value, and then we take the mean of that value. So we square them all, we take the mean, we get a single value. The problem is that value is still in squared units. So it's going to be huge, and it's not going to make a whole lot of sense, and it's not going to be relevant really to the data that we have. So we need to take the square root of it to convert it back to single units, not squared units. And we do that by taking the mean squared error, and we, instead of raising it to 2, we raise it to 0.5, which is another way of getting square root. So we'll go ahead, first of all, do this, and then we'll run this, and it gives us 6.6030, which is a pretty high error when you consider that that is the amount of difference between the predicted value and the actual value. But that's in tens of thousands of dollars. So that's a pretty high amount of money, about $60,000 error. So well, let's look at it visually then. Actually, before we look at it visually, let's see how good the how closely related the prediction and the actual median value are. We use the correlation coefficient for that. So we do core coefficient, and then we just access the two variables, df prediction and df median value. We run that, and it tells us we have just shy of a 0.7 correlation. Now that tells me that that's not a particularly great model. It's not terrible, but it's not particularly great. Two things actually that tell me about this model. One, we have a pretty high mean squared error. which tells me there's a lot of variability between the prediction and the actual. And we have a kind of a moderate-ish kind of going on high level of the correlation coefficient. So it's okay. It's not going to win any awards. It's okay. So the last thing we're going to do is we're going to take a visual of what the plot looks like. So we'll just set up the variables for that. And we're going to set x equals, and these are just, I'm reusing x and y. X equals prediction and y equals median value. And I want to visibly look at how well those things plot against each other. With a correlation of 0.6 and an error of 6.60 relative to the values of the median value, I'm going to expect that it's going to look okay, but not great. Down here, we've got a number of things going on. First of all, we'll set up for our titles. Our plot title is going to be actual median value versus predicted value. We set up, like we've done in the past, a font dictionary where we select our font name, which is our key, and that's our font. And then we select our font size, another key, and that's our font size. Dictionaries are always in curly brackets, but the entire thing's enclosed in parentheses because we're setting the plot title. We'll also set the Y label and the X label, the median value and the predicted value, and you've seen that done before. Then we'll go ahead and run the scatter plot. In addition to running the scatter plot, we're going to set up and generate a trend line. And this is kind of a more involved way of setting up and generating a trend line than we did up here. And I might recommend that we use this instead because this is a lot easier than what we're about to do. But anyway, we set up a couple of variables. Z is going to be a polyfit of XY with a width of 1. And then we'll set up to actually build this P equals poly one-dimensional Z is basically telling us how to draw this and what it should look like. And the last thing that we say about it is we want it to be red with dashed lines. It's just an abbreviation for that. And then the very end we'll say plot show to just go ahead and show the plot. And it fails. And let me see why. Probably because I didn't, oh yeah, I didn't run my, there we go. We've got to run that first before we run this. And we get our trend line. And our trend line looks okay. Again, it's got, it shows the bit of scatter, maybe some stuff not as clean as we would like. But at least gives us a visual. So, all right, so to recap, what we did is set up our libraries, loaded our data, built our reg variable that we'll use for linear regression, set up our different variables. Remember, one of them had to be set up as a data frame. So this is, even though it's a single column, it's forced as a data frame because of the two brackets. We did a little visualization to look at how the two variables compared to each other. Then we used the SNS reg plot function to be able to see that with a trend line to give us an idea of what we were expecting to see when we ran the regression. Then we ran the reg fit for XY, which is the actual regression. Remember, everything's reg.something. And that sets up our variables, which we can then look at. Here's our coefficient or our slope, and here's our intercept. Now we can go ahead and take that reg variable again, and this time we're going to predict an x and drop that result into a new variable called predict, or PRED, that is part of the data frame. Now that becomes variable number 14. Then we can take a look at all three of those and see how that was actually applied. If we take 6.75, we multiply it by the slope and we subtract out the negative intercept, we get the predicted value. Then we calculated the error value by taking the predicted value and subtracting out median value. And we converted that to, first of all, a squared error, and then we took the square root of the error, and it gave us an idea that we have a pretty big kind of level of error. We ran the correlation coefficients between the predicted value and the median value. Then we reset the x and y variables and came down here and did a little bit more involved plot that showed us kind of pretty much what we'd seen before and what we're expecting to see and the level of scatter. All right, your assignment for this week, I'm going to give you a data file. I am not going to give you a script. I'm going to ask you to go in and create a Jupyter notebook that will do all of the things I've done here, but you're going to do it on a different data file, and you're going to do it on 2 different fields. As I submit to you the assignment, I will give you the specifics in the assignment. Okay, if you have any questions, let me know.